Hello again. Many of you are probably very familiar with my face, and I look forward to when I might be able to meet some of you in person at a future Red Adoption Research Program conference or event. For those who don't know me, my name is Dr. Holly McGinnis, and I am an assistant professor at Virginia Commonwealth University. I am an adoption scholar whose work focuses on improving outcomes across the lifespan for youth and adults who have been adopted. I was adopted from South Korea and raised in a white transracial family. And I started a group for internationally adopted adults also known as in New York City, that's currently celebrating its 25th anniversary. So shout out to any members who are joining us tonight. I also worked as a policy director at the Donaldson Adoption Institute before pursuing my doctorate in social work. I had the honor of being invited by Dr. Grodevant to be the inaugural program chair for the 2020 RUD Adoption Research Program Conference, Adopted Adults Connections Across Generations. Of course, we had to reimagine and reinvent this conference from its original in-person format, which would have happened in April of 2020. And we really thank all of you for keeping with us and tuning in to what has become a year-long virtual program. I want to especially thank Dr. Hal Grodevant, Rudd Family Foundation Chair of the UMass Rudd Adoption Research Program, Dr. Jen Dolan, Program Manager of the Rudd Adoption Research Program, and Amanda Moore, Events and Communications Manager, without whom these sessions would not be possible. So I'm really excited to launch the second of our three-part spring series that continues our conversation on what adoption looks like through adulthood and some of the cutting edge horizons that I don't think adoption professionals even anticipated just 15 years ago. One of those cutting edge horizons is the use of genetic testing for health and birth search, which is the focus of tonight's session. To provide a little personal context, about a decade ago, I began hearing in the Korean adoptee community about efforts to get adoptees to use the commercial genetic kits 23andMe. The kits were very expensive back then, and I remember one generous Korean adoptee began to pay for them for anyone who wanted them. There appeared to be some general knowledge that we needed to put our DNA in the same bank for any hope of connection, but there also appeared that there was a lot that we didn't know. And in fact, in 2015, a group of Korean adoptees started the organization 325 Camera to intentionally distribute DNA kits to birth family members in South Korea to increase the odds that biological members could be found. I've been curious about these connections through genetic data banks and how they've helped adoptees in their search for connection with biological families, as well as the search for identity. So I'm really excited that our first presenter, Dr. Greg Barsh, faculty investigator and faculty chair at the Hudson Alpha Institute for Biotechnology and professor of genetics at Stanford University, will begin tonight's session to help us lay people better understand human genetics, DNA testing, and also share his personal experience as a domestic adoptee who recently identified his biologic relatives through 23andMe. Next, Dr. Rich Lee, Distinguished McKnight University Professor in the Department of Psychology at the University of Minnesota, Twin Cities, will share some of his latest research on genetic testing for birth search and health among Korean adoptees, including perspectives of adoptive parents. Dr. Lee is a US-born second-generation Korean American raised in a Korean immigrant family. Although he's not adopted, he is married to a Korean adoptee who is our fourth amazing speaker tonight, Heewon Lee. We will then shift to think more about genetic testing for health information. Dr. Thomas May, Floyd and Judy Rogers Endowed Professor at Washington State University College of Medicine, and an adoptive parent, will expand our thinking about the challenges and limits of genetic testing for health. Dr. May will walk us through some of the risks of genetic testing, especially when it's used to fill in gaps in a family health history, underlining the vital role that family health history still holds for adoptees in the age of genetic testing. And finally, Heewon Lee, who is a licensed genetic counselor practicing at Francis Cancer Center in Minnesota, will educate us about genetic counseling and genetic testing. This is where the motivation for tonight's session has become quite personal for me. In January of 2020, I was diagnosed with early stage breast cancer. And of course, like so many adoptees, I did not know my biological family history to help explain my risk. Heewon was instrumental in helping me understand the lingo and what to ask for when I went to see my genetic counselor. I'm really glad to report that a year out of treatment, I have no evidence of disease. And yet the diagnosis fundamentally shattered and rebuilt my entire life. I was considered young, under the age of 50 when I was diagnosed. I am busy parenting young children. I have a career, and like all of us in the past year, was navigating not only the pandemic, but also the rise of racial violence in our society. It made me really think of how many of my adoptee sisters and brothers, especially those of the largest cohort of Korean adoptees who came in the 1970s and 1980s, who are now reaching middle age, will also be confronted with such life-threatening illnesses. Sadly, in my group of 10 close Korean adopted women friends, half of us have been diagnosed with breast cancer over the past 6 years. So this has been my motivation to conduct my current study that's going to be launched this summer, focusing on understanding the scope of health and well-being among adoptees in adulthood. So it is with a deep sense of urgency that I hope tonight's session, it will elevate these issues and that more research, practitioners, and members of the adoption constellation will be educated and advocate. So just to touch on some logistics, please use the Q&A feature in the webinar and to put your questions in, and not the chat feature. And if we don't get to answering your questions by 8 p.m., put them in there anyway, and the speakers will try to still respond to them. But before we move into our program, I just want to give a pause, especially since 2 of our speakers are from Minnesota, to give recognition to the challenging week this has been for those, especially relating to racial justice. So I invite Dr. Rich Lee to just provide us with a pause.
Thanks, Holly. Yeah, welcome everyone. I asked Holly if we could take a minute to just acknowledge the racial trauma and the challenges facing not just our state, but also our country right now. As many of you are already aware, the trial of Derek Chauvin for the murder of George Floyd is currently underway. And just this past weekend, there was another police murder of a Black boy, a 20-year-old young man, Dante Wright. And it's been a very exhausting time for us here. And yet we recognize that we need to stand in solidarity with our brothers and sisters across racial lines. And one thing we've learned by doing research in adoption is that many adoptees are in transracial, multiracial families. And these are issues that affect each and every one of us. And so I just wanted to acknowledge this before we began today's session. Thanks, Holly.
Thank you, Rich. Okay, inhale and exhale. Now I'd love to give the floor to Dr. Greg Barsh. And Greg is going to work on, he's going to share his screen because human genetics is a little complicated.
How's that? Can people see this okay?
Yes.
That's great. Okay, well, yeah, thanks. Welcome everyone. Thanks, Holly, for and the opportunity to be part of the Red Adoption Program. Like most of my fellow panelists, you know, we've living in a new world, getting used to the Zoom talks, and so I hope that the audience will be able to at least get some of the same flavor that we would have if we were able to do this in person. So I should start with actually a disclosure, and that's I don't do research on adoption. So, if you're here to learn about research on adoption, you can tune out for the next 10 or 15 minutes and come back and listen to Rich and Heewon and Tom. But what I do is research on DNA. So I'm a geneticist. I'm a human and medical geneticist, and so I spend my day job is to study how DNA tests can be applied to individuals in the real world, both patients who have questions about whether they might have genetic conditions, and also individuals who are just interested in learning more about what DNA can tell them. And so what I want to do over the next, say, 10, 15 minutes or so is give you a little bit of, I would say, sort of basic background about DNA and biology. And so it's sort of, genetics 101. And so I'm going to divide my comments up into sort of three areas. The first of those are family trees and biology. The second is how DTC, direct-to-consumer genetic testing, like 23andMe, Ancestry.com, or MyHeritage, can be applied to think about and understand family trees, and then tell you a little bit about my own experience, my own family tree, and the lessons that are learned. And I wanted to start with this slide because this is a really big family tree. So this is the family tree that shows all of life for the last billion years or so. And the main point to get out of this is that it's a tree, and that every organism, from a bacteria to a fish to a mouse, we're all related. We all share DNA at some level. And it's that principle that all organisms share DNA that makes it possible to understand how different organisms are related to one another, whether we're talking about organisms within the same species, like two humans, or organisms within different species. So the one way I like to think about this is quantitatively, and that's just the amount of DNA sharing that's present. And so if you think about humans, it turns out humans versus like yeast that you would use to make beer or bread, 30% of their content at the gene level is identical. In a mouse, about 90% of the mouse DNA is the same as human DNA, and vice versa. Humans and chimpanzees, even more. And human versus human is actually not that much higher than humans versus chimp. It's about 99.9%. And so it's really striking, right? The amount of DNA that's shared across different species. And you can get a sense now that DNA sharing is not like a on or off thing. It's something that's very quantitative. And as you get closer, you see the greater amount of DNA sharing. Now this kind of DNA sharing that I'm showing here between different organisms is a little bit different than the kind of DNA sharing that you might be used to if you're a client of one of these direct-to-consumer genetic testing companies. And so when you get your results back, if you've gotten your results back, and you look at your family tree, and I'll show you my results a little bit later. And they talk about, oh, well, you have, 50% sharing or 25% sharing. That means a little bit something different from the context I'm talking about it with, between different organisms. And I'll get to this point a little bit later, but the critical difference is when we're talking about close relatives and using direct-to-consumer genetic testing, we're talking about shared chromosomal segments. And I'll explain what that means in just a minute. But before I do, I want to just give you a sense of both similarities and differences between different humans. So here is a DNA sequence. This is about 1,000 letters of the genetic code, 1,000 letters of DNA. It's a small fraction of the DNA that's present in all of us. The genome in all of us is about 3 billion base pairs. And that 99.9% sharing means that about 1 out of every 1,000 letters is different. And so here I've just sort of highlighted, this one letter. So if you imagine sort of comparing two humans to each other, or even if you were to compare one human to itself, and this is an interesting notion that, remember, probably everybody knows that you get half of your DNA from your mother and half of your DNA from your father. And so all humans actually share two sets of DNA, one from their father and one from their mother. So you can compare one human to another human. You can compare the DNA that you got from your father to the DNA that you got from your mother in yourself. And if you do that, you will still see that there's about 1 in 1,000 differences. So on the one hand, at this slide, that doesn't look like very much, but the genome is big, it's 3 billion. And if you do the arithmetic, that's about 3 million differences between people or even within an individual. So within all of us, we have 3 million differences within our own DNA. And those differences are called single nucleotide variants, or SNVs for short. And that is basically the raw material that drives all of genetic testing, or almost all of genetic testing. Now, when we talk about building trees, and so the tree of life I just showed you, that's built basically on these kind of SNV differences between organisms. And we can also use SNV differences between humans to build a big human family tree. And that's what I'm showing right here. So across 150,000 years of human evolution, all humans are, again, about 99.9% identical. But you can use the amount of SNV sharing between humans from different populations to build a human family tree. And you can see that, individuals, say Italian individuals, are more closely related to Russian individuals than they are, say, to individuals from Papua New Guinea or San individuals. And so this is a big human family tree. Now, what about the kinds of family trees that we're talking about when we think about parents, children, aunts, uncles, cousins, nieces, and nephews? And here we're talking about the kind of sharing that relates to chromosomes. So again, you get half of your DNA from your mother, half of your DNA from your father. That comes in chromosomes. Every human has 23 pairs of chromosomes, 23 from their father and 23 from their mother. And here I'm just showing a very simple cartoon of a pedigree. And probably everybody knows in this pedigree that the squares are the males, the circles are the females, the horizontal line means a marriage, and the vertical line means children. So this is a pedigree in which there's a man and a woman, and they've had 2 daughters and a boy, with the boy in the middle. And this is just a diagram that indicates that, well, there's 2 sets of chromosomes, say the red and the orange chromosome here. And these chromosomes can be passed on at equal chance. And so say, here the daughter has a 50% chance of getting the orange chromosome from the father, which she did, or the red, she got the orange chromosome, and whereas the son got the red chromosome, whereas the daughter got the orange chromosome, and so on. And if you just think about this a little bit, what it means is that you can have 2 siblings, now these, so like a sister and a brother here, who have the exact same set of chromosomes. You don't see that here because each of these 3 siblings has 3 different sets of chromosomes, or they could have all the same chromosome or all different chromosomes. So that's possible because of the way that the DNA is passed down. And that accounts principle of genetics accounts for the kinds of sharing and the numbers that you will see when you think about DNA sharing from, say, 23andMe or Ancestry.com. Because every human gets, say, half of their DNA from their mother or half of their DNA from their father, it means that exactly the amount of DNA sharing that an individual has with their mother and father is 50%. So when I say that here, so the SNV patterns, they delineate shared segments. Offspring have exactly 50% of their segments from each parent. But because the siblings can get either set of chromosomes, it can vary. And so on average, if you look across, 100 siblings and compare two of them, each pair will have about 50% sharing, has on average 50%, but it can vary, from one sibling pair to another. And you can use the exact same principles to infer the amount of DNA sharing between other kinds of relative pairs. So first cousins or second cousins are a good example. Okay, so just to sum up what I've said so far, DNA sharing between relatives means really shared chromosomal segments. And then the other point here that I want to make, I've sort of made it implicitly so far, is that if you forget about the segments for a second, you just think about the SNVs in general, you can build the kind of big family tree with related human populations. And that's the kind of data that a direct-to-consumer genetic testing company will use to infer ancestry. So when you get your results back from 23andMe and they say, oh yes, you are, 30% of East Asian ancestry, that's based on this SNV pairing. It's not based on the shared chromosomal segments. So I just want to spend the remainder of the time then talking about my own experience, and in doing so, give you an example of how these sorts of quantitative DNA sharing, both the segments and the SNV sharing, come into play. So as Holly mentioned, I am the product of a closed adoption, and this is the medical geneticist's symbol for adoption, the little red brackets here. And the dotted line then is refers to my now adoptive parents who both passed away about 10 years ago. And I, like Holly, for the last decade, have been really interested in understanding more about genetic testing. And not so much because I was adopted. I was interested because this is what I do. This is my bread and butter. My day job is to study genetics. And in fact, when a lot of the people that I used to work with now work at 23andMe. So, we're good friends. We know each other. And so I was an early 23andMe customer. And when I got my data back from 23andMe, this is what it looked like. It said, Greg, you are Ashkenazi Jewish, 98.6%, and the other 1.4% is broadly European. Now that was like 10 years ago. And then like a few years later, I got an update from 23andMe. They say, we have new information. You're not 98.6%, you're 99.5% Ashkenazi. And so you might ask, what changed? Well, the DNA didn't change. And the results didn't change. It didn't get any better. They had more information, and the information that they used to assign an individual to a particular ancestry group was different. And this is something that does change over time. And it not only changes over time, but it changes over platforms. And so I was pretty curious. And then, so a couple of years ago, I said, well, I wonder how 23andMe does against Ancestry.com and MyHeritage. And so I sent new samples of DNA to those companies. And I was actually pretty interested to see that Ancestry.com thinks that I'm much less Ashkenazi Jewish than, say, 23andMe. MyHeritage, they agree with Ancestry.com. So who's right? I think to some extent they're all right, and it's just what this reflects is not errors in the test. Everybody is working with basically the same platform, and the quality of the results are the same. It just has to do with the inference of that the company is using to say, oh yes, well, you're of this ancestry versus that ancestry. And that gives you a sense, if you're, you know, a customer of one of these companies, of sort of the error inherent in this kind of approach. Now, I have to say that, you know, when you look at this, you might think, wow, I mean, I looked at this and I thought that looks pretty boring. You know, not a very diverse family. But it turns out that even though I'm not very diverse, my family is pretty diverse. And that's because of my wonderful wife. When she did her 23andMe test, it looked like this. So she is 39.2% Italian, 15.6% broad and Southern European, and so on. And for those of you geneticists in the audience, and sort of you can think about this for the next, you know, 5 minutes or so, you know, what is her ancestry? Where are her mother and father actually from? So that's a bit of a genetic puzzle for those of you who are interested. Okay, so my DNA family. Let's talk about relatives now. So I was curious. I knew I was adopted. I wasn't, you know, and so I thought, well, maybe there'll be somebody out there. So I had 1,081 DNA relatives. So does this mean that I have 1,081 first, second, and third cousins? And the answer is no. And the reason is because the approach that 23andMe and the other companies use to try and figure out the relationships sometimes can get confused between the chromosomal segments and the SNVs. What it means is that I have 1,081 individuals, or there's 1,081 individuals in the 23andMe database who have some degree of SNV sharing with me that is greater than random. But once you get beyond about a first cousin or so, the ability of the algorithms to basically infer, you know, accuracy is not very good. They can tell you they can get, you know, half siblings, they can get, you know, offspring, they can get full siblings, but beyond that, there are lots of opportunities for confusion, and I've seen a number of areas where they are confused in those relationships. Now, the other thing I want to just mention is that, you know, I'll be interested to hear how many DNA relatives Holly has, because that varies a lot, right, from one individual to another. And the question is, why is that? And there basically are three reasons. One is that the platform is different. And by platform, I don't mean the chip that's actually used. All the chips are pretty much the same. What I'm really talking about is the client base. And so these different companies have different representations of people who, and so people who have sent in their DNA. And so 23andMe and MyHeritage.com, it turns out, have a lot of Ashkenazi Jews who have sent their DNA in. Ancestry.com doesn't have as many. I have fewer relatives at Ancestry.com. And so population plays a big role, depending upon the ability of individuals to infer, you know, depending upon which population you're from on your ancestry, that'll affect your number of DNA relatives. And then, of course, inference errors, as I mentioned. Okay, so my personal story here is that my daughter is also on 23andMe. They got it perfect. You know, 23andMe got it 50.0% DNA sharing. It's perfect. And, you know, for the first 8 years since when I, you know, was a 23andMe customer, I knew that I had, you know, some DNA relatives out there. I had a couple second cousins, but of course, I didn't know that they, you know, as I said, you know, were they really truly second cousins or not? Turns out they're not truly second cousins. I'll get to in a minute. But yeah, you know, 4.5% DNA sharing is significant. At some level, I knew that I was related to these individuals, but I never really bothered to do anything about it because sometimes it's difficult to trace with this kind of level of DNA sharing. And then a little less than 3 years ago, there was a surprise. I logged into 23andMe one day and I discovered that I suddenly had Lisa turned up. So Lisa, a half-sister, 23andMe predicted a half-sister with 24% DNA sharing. So, and I knew that they had it right. And so now I was really curious. I thought, wow, I never knew I had, I knew there could be out there, but this was pretty fascinating. So I sat around and mulled that over for a week or two. And then Lisa sent me a note. And so here's the note that I got from Lisa on July 17th. It says, not sure who this message is going to. Apparently I have a half brother, not what I expected to find 3 weeks ago when I got my DNA results. Weird, awkward, and interesting. Just thought I should reach out in case someone was looking for answers or info regarding their family. And I thought at the time, this is kind of fun. I was motivated to sort this all out. So I replied to Lisa, we exchanged, emails and contact information. We've gotten to be very good friends. And she said, I'm just not sure how this happened. I don't know how all this DNA stuff works. And I said, I can help you with that. Lisa and I together, we sort of sat down and said, well, do we share the same mother? We share the same father? How did this happen? What do you know? And basically, here's what we figured out is that, and this is now a little pedigree here. So here's Lisa over here. Here's me over here. And it turns out that we have the same biological father, but different biological mothers. And I have to say, this was a surprise. In fact, I think it's fair to say it was a shock to Lisa because she did not know that her father had adopted her, and she was unaware that she had that her adoptive father was not her biological father. And I think that it's also fair to say that the two of us, that is Lisa and I, have grown closer by exploring this bond and learning about our biological relatives. I also, just to finish the story on my side, I was motivated. This was a positive experience to get to meet a new half sibling. And so I wanted to kind of track down the rest of my biological relatives, which turned out to be a surprise and a very pleasant surprise. So it turns out that Lisa and my biological father has an additional 6 children that he knows of by now actually four different mothers. And my biological mother has 2 daughters, and each of whom have children. And over the past, I would say over the next 6 months or so, I formed, all of us sort of got to know each other at some level or another, which was actually a very positive experience for all of us. I'll say that, and these stories, they differ for everybody. It's a very sort of personal experience. For me, my biological father, I know a little bit. I don't know him very well. My biological mother and her family, though, I've gotten to know very well. We're very close. In fact, so this whole group of the family right here, we actually had a biological relative reunion, about 1.5 years ago, which was a lot of fun. So for me, the direct-to-consumer genetic testing and the search has been a very positive and affirming experience. So the take-home lessons for me are that, we all share a lot of DNA, that you can infer these close family relationships based on the pattern of shared SNVs, which tell you about chromosome segments that are shared, that the different platforms are all basically the same and very reliable, but you might get different results depending upon the algorithm that's being used for ancestry and the client base at each of the major direct-to-consumer genetic testing companies. And that I know that Rich and Tom and Heewon are going to touch on this question of when you engage in this kind of activity, it can have impacts that go beyond yourself, right? So for me, this is what I do for a living. I kind of knew what I was getting into. For Lisa, it was a surprise. And there are many, many stories like that. And I think the more that we as adoptees can be educated about the science and the biology, the more that we can understand both the potential rewards and the risks. So I will stop there, turn it back to Holly, and go from there.
Thank you so much, Greg. I have a lot of questions, but I'm going to hold them to about 7:30 when I'll open it up for all of us to ask questions. So for those who have just joined us, please put your questions in the Q&A. And we're going to shift over to slides for Rich Lee, who's going to expand on some of the adoption research that he's been doing on genetic testing for search and health. There is a question that has been posed, and I think Amanda's going to work on pulling up Rich Lee's slides. And again, we are going to be using one person moving the slide, so Rich will have to, we'll be cueing our Amanda. But I think Rich's presentation will get at this one question, which I think is relevant right now, is what's the confidence interval for these genetic tests? I've seen many transracial adoptees have identity crisis over discovering they have less than 10% of something they didn't expect. Chinese adoptees with less than 10% of Vietnamese. I've read that less than 10% is negligible. Also, disregarding genetic tests don't account for geopolitical borders. So I don't know if, Greg, if you have a quick answer to that one, or around the confidence intervals. Oh, Greg, you might be on mute. And you're on mute, Greg, if you want to just respond quickly. Oh, Greg, you're on mute. You'll have to unmute. Oh, Greg, you're still on mute. Okay, there we go.
Sorry, yeah, I couldn't unmute. I was trying to mute. Okay, so 10% is a lot. 10%, I think, for any relationship is meaningful. There certainly are confidence limits around this, and in fact, I would say that anything above 3 or 4% is meaningful. Now, the assignment of that relationship to a particular population is something that can vary tremendously among, depending upon the algorithm and the reference populations that are being used. But yeah, I would say that if you have above 3 or 4%, then that's real at some level.
Great, thank you, Greg. Okay, now we're going to pass the baton to Rich Lee.
Thank you, Holly, and thanks, Greg, for that opening presentation. And really, my presentation follows nicely with Greg's because our project actually began in 2007, just as 23andMe first launched its direct-to-consumer genetic testing. And at that time, I was actually not at all interested in genetic testing. It just so happened that Dr. Hal Grotevan, who is now the director of the Rudd Center, had a student who was graduating that I hired as a postdoc in my lab, Yvette Perry. And she was interested in genetic testing. And so she asked if, as we were launching our first project on Korean adoptees, if we could include some questions about genetic testing. She was prescient in a way that we hadn't anticipated. And so this project, which began in 2007, started with a survey of over 500 families who had adopted children from South Korea, and the kids were now between 5 and 18 years old. We then followed up with a portion of the younger children 7 years later in 2014. And now in 2020, just recently completed a third wave of data collection on the original sample. We were not able to track everyone down, but we did track down about a third of the adoptees in our original 2007 sample. And it's the data I'll be presenting today is from that latter, or this most recent survey that we just completed. Next slide. So in this survey, which was actually over 170 respondents, out of 157 who answered this question, we found that over a third of the adult adoptees who are now between 18 and 30 had searched for birth family. They also reported that 17% of them had adoptive parents who had previously searched, and also another 20% reported that they weren't sure or didn't know if their parents had previously searched on behalf of them. So you can see here that in many ways, Greg is not alone in having questions about who his birth family might be using some type of genetic testing, in this case, direct-to-consumer ancestry testing. One of the interesting things we found as well in this survey was that the majority of adoptees reported that their parents would be emotionally and financially supportive of their child searching for birth family. And that, of course, could be a selective sampling based on who we recruited, as anecdotal and field reports would suggest that many adoptive families have mixed feelings about adoptees searching. So we found that to be notable as well. We also found that about a fifth of these adoptees had actually found birth families, but not all of them had actual contact with the families. So there's quite a bit of variability. I think one of the things that is important to recognize is the fact that not all birth searches, even though are successful, and even when they are successful in identifying biological family, it's not always the case that the birth family is wanting to have contact, or they may have some contact, but it's much more limited. And so this is where it's really important, as one is going through a search, to really be prepared and to have a lot of resources and support available to you, so you're able to sort of navigate the variety of ways in which the search and reunion may occur. Next slide. So in this last survey we conducted, unlike the earlier ones, we differentiated between direct-to-consumer genetic testing kits like 23andMe and Ancestry.com from provider prescribed or clinical genetic testing offered. And when we looked at DTC, or direct-to-consumer genetic testing, we found that, again, almost a third of the adoptees in our sample had already used one of these genetic testing kits. And the top reason for it was simply curiosity, which I think is actually the words that Greg used in describing his reasoning. But then we see that that was followed by a right to know one's genetic lineage, about identity development, about wanting to locate birth family, not in South Korea, but wanting to see if there were any birth family who had migrated to the US or Canada, as well as some health and medical needs as top reasons. For those who had not engaged in, used direct-to-consumer genetic testing, we again found that curiosity was the top reason, but we see a shift, and now we see health and medical needs being another reason why they might want to take this type of testing, followed by wanting to locate birth family, not in North America, but in South Korea, and again with identity development and the right to know genetic lineage. Next slide. When we think about, then we asked how many were interested in or had taken clinical genetic testing, and only 5 out of the 165 who answered this question had some type of clinical genetic testing completed. And the reason among these 5, so this is not a large sampling here, was that they were interested in identifying a genetic disease, right? So their provider wanted them to do this for diagnostic reasons, followed by, for a few, pharmacogenetic reasons, and I think in 2 instances, whole genome sequencing. But what was interesting was that almost half of the Korean adoptees were interested in clinical genetic testing. So here we're starting to see a shift now. We have a number of adoptees who are interested in direct-to-consumer genetic testing, which is by and large to identify one's ancestry, perhaps finding birth family. But when we go to the clinical side, which is more relevant for identifying information relevant to your health, we see that 45% were somewhat to extremely interested. And unlike those who had already completed it, those who were interested in clinical genetic testing, it was mainly to identify risk for disease as the top reason, followed by diagnostic genetic testing and also screening genetic testing, that is, looking for carrier conditions, for example. Next slide. The last thing I wanted to sort of end with here, and this is drawing from our 2014 sample where we surveyed adoptees back when they were adolescents and their parents. And we have the same data for 2020, but I have yet to analyze that. But in 2014, one of the really interesting things here that we see is that parent interest in genetic testing, which is broadly defined here, so we didn't differentiate between direct-to-consumer and clinical. But parent interest, as you can see in the columns, no, yes, did not match with the adolescent interest. In fact, you see that only 25 pairs of adoptees and parents were in agreement that they both were interested in genetic testing for the child. And a lot of discrepancy, both parents being interested and adolescents not, but also adolescents being interested, but parents not. And we do see 35 where both the parent and the adolescent were both not interested. And so I think this is a really interesting finding, because we can see that there are oftentimes situations where parents are wanting to pursue genetic testing, but the question is it in the best interest of the child? Or is that child ready for this type of information? On the other hand, we also can see where children, right, in this case adolescents, have a curiosity and an interest, but the parents themselves may not be ready. So for those who are social workers, those who are working in adoption agencies or providing other kinds of care providers, it's important to understand that parent and adoptee may not always be on the same page. And that is something that providers need to work with adoptive families on processing, right? So the last thing I want to bring up that I didn't touch on here, but that is important, is that, you know, another utility of direct-to-consumer genetic testing, I can say, for adoptees is the fact that adoptees, as they move into adulthood and begin romantic relationships, they themselves may want to know whether or not there is a relationship with their potential partners. That is actually not something talked too often about, but it is something to take into consideration. And there have been some news accounts in the past, in the case of domestic adoptees, where they discovered that, you know, their best friend was their biological sibling, or a romantic interest was their sister or brother. And so you could also imagine situations when individuals are not necessarily even aware that they're adopted, right? But if they grow up and don't really leave a small community, that these are other considerations to have. So even though the work I'm doing is on international adoption, you can see sort of generalizations that could occur to domestic adoptions as well. So with that, I'm going to leave it and let Holly introduce Tom. Thank you.
Wonderful. Thank you so much, Rich. A lot of data to process, and especially the differences around kind of those reasons and motivations for the different kinds of tests. Okay, so now I'm going to hand the baton over to Thomas May.
All right, I'll go to the first slide right away. All right, I want to talk a little bit about the use of genetic testing to fill gaps in family health history. I want to point out on this slide, the very top line, you'll see the terminology FHX, which I am using as an abbreviation for family health history. The work that my group has been doing started with the idea that adoptees represent a significant portion of the US population, about 2.5% of the US population. That's about 7.8 million adoptees, and that's just in the United States. The UN estimates that there's a global adoption of about 260,000 adoptions a year, and that the number of children who've lost both parents is at least 60 times that number. And that's from the United Nations adoption trends back in 2009. Many of these adoptees lack access to family health history information. Obstacles to having access to this information include closed adoption records in many areas, financial and logistical challenges to obtaining such information, emotional hurdles, a lot of secrecy and inaccurate medical histories that have been added to medical records in order to facilitate adoptions in some cases. And even for open adoptions, we find that family health history is available for less than half of biological fathers. And even where it is available, it is not an iterative process where we get updates of family health history as new conditions arise or are noticed within a family. So it's a real lack of access to this information that is available to the majority of the population. If you could go to the next slide. The implications of this is that family health history has a number of uses, but primarily one of the strongest uses is in screening. It's in the implementation of screening protocols for health conditions. So I'll give you a quick example. If you have a family health history of breast cancer that constitutes a 20% or more greater risk of breast cancer in your family history, your doctor, or the recommendations anyway, screening recommendations, are to utilize MRI adjuncts to mammographies for screening for breast cancer in order to detect it at an earlier stage, as MRIs are more sensitive and better able to catch breast cancer at an earlier stage. If you don't have family health history available, there would be no way to know that you are at 25 or 20% or more greater risk. And so you may be denied access to this early intervention that would be implemented on the basis of family health history. And it really sort of illustrates a logical dichotomy that faces any primary care physician who has a patient, be they adopted or not adopted, that lacks access to family health history. Do they treat them as if they are at population risk, that is the risk of anyone in the society who does not have increased risk? Or do they treat them as if they are at high risk? If physicians would approach all such patients as if they were at population risk, then these patients would be denied the benefits of early intervention that would be available to the rest of the population based upon their access to family health history. On the other hand, if physicians were to approach all such patients as if they were at high risk, because they lack access to reassuring family health history, that there is no history of breast cancer in my family, therefore I'm not at significantly higher risk, then many of these patients might be subject to over-intervention and unnecessary exposure to potential complications, right? So it's a double-edged sword, and which sort of risk we are exposed to would depend on which side of this logical dichotomy you fell, or your primary care physician fell. But either way, you would be worse off than if you had access to family health history. Next slide. So how do we fill the gaps in family health history using genetic testing? Well, genetic testing seems like it's a logical way to fill some of these gaps, because when we're talking about family health history, we're talking about inherited disease risk. However, there are some challenges that we have to overcome. First and foremost, in the past, most genetic testing has been interpreted in the context of family history or triad testing of close biological relatives. And so we can do, as we've seen with 23andMe, as Greg has discussed, for example, there are conditions under which we can examine what variants you have and how that associates or correlates to different disease conditions. However, some of these have very high ratios of correlation, and some of them have very low ratios of correlation. And a few years ago, 23andMe, for example, offered something called a PGS test, a personal genomic screening test, that the FDA asked them to cease and desist because they weren't able to verify the algorithms that they used to associate certain variants with certain medical conditions. And when 23andMe would return results and estimate your risk of contracting certain conditions. In addition, what studies we have seen conducted on genetic testing for some conditions where there are very high levels of confidence between the variant and the associated condition, such as the variants associated with Lynch syndrome, have shown that that there has been very little added utility for genetic testing to use it over using family health history alone. But of course, as you can expect, this sort of study would neglect the value of genetic testing for those who lack family health history, as it's assuming that you have family health history, and that's what makes the genetic testing of little added benefit. But if you lack family health history, there can be tremendous benefit. However, we have to overcome these sort of population-wide sort of assumptions in order to get this to be recognized as a valuable tool within the medical community. Next slide. So a couple of years ago, a geneticist and I did a study where we went through the literature and we looked at the tests or the costs that were associated with late stage and early stage intervention for three of the conditions that are of the highest confidence level in being able to use genetic testing to identify risk. And that's BRCA-related breast cancer, BRCA-related ovarian cancer, and Lynch syndrome. And we looked at the differences in costs for early stage intervention versus late stage identification of the disease. And we looked at the savings that could be realized if those who lacked access to family health history were granted access to a risk stratification mechanism that would allow this to be identified at an earlier stage. And we even adjusted these numbers to account for the fact that not everyone would uptake this sort of testing or uptake the interventions if risk were identified. We used numbers that were available in the literature concerning how many people who are identified with the BRCA variants elect to undergo different types of intervention or preventive intervention. And we saw that just over these three conditions alone, it's very likely that there would be not only cost neutrality, but probably cost savings. And we did these numbers. You'll see here, it looks like it would be cost neutral, but we erred at every single point on lower savings and higher costs of testing. So this was a very conservative estimate of the potential costs of implementing genetic testing for those who lack family health history. Next slide, please. But these aren't the only sorts of problems and challenges that face the use of genetic testing to fill this role as a way to fill gaps in family health history. And some of the other risks are what I like to call neglected risks from genetic testing, although they're not neglected in the genomics community at all, right? They're just often neglected among those who undertake direct-to-consumer genetic testing who are unfamiliar with some of these problems. And I just want to mention a couple of them here today. One is the risk of false positives. Here's a newspaper headline from the Huffington Post of a woman who had a direct-to-consumer genetic test prior to the FDA issuing their cease and desist order. The results indicated that she was BRCA positive, that on the basis of this, she followed the lead of Angelina Jolie, had a double mastectomy. But what she failed to do and failed to realize she should do is have the tests results that were returned by 23andMe clinically confirmed. So oftentimes, direct-to-consumer testing does not include clinical confirmation. If you go to a medical clinic, for example, or a university clinic, and they do genetic testing, if you come back positive, they will send it off for what's called Sanger confirmation to verify that this is not a false positive. And one study that was published back in 2019 found that of the positives from direct-to-consumer genetic testing, as much as 40% of the positives were false positives. And so this clinical confirmation is extremely important, and it's something that's very important for those who undertake genetic testing for healthcare purposes are aware of. Next slide, please. Another type of neglected risk is one that I call the risk of false reassurance. And this is where you go in and you get your BRCA test. It comes back negative. You're very happy, and you consider yourself not at risk for breast cancer because it came back clean, without realizing that only about 7%, in fact, it's a little less than 7% of breast cancer cases are BRCA related. That is the vast majority of breast cancer cases, and including inherited breast cancer cases, are not BRCA related. We just don't know all of the variants that are associated with breast cancer yet. BRCA is one that we've identified with high confidence. We know that if you are BRCA positive and it's not a false positive, you are indeed at a higher risk of breast cancer. But if you come back BRCA negative, you should consider yourself still at population level risk. You haven't identified a lower risk at all. So oftentimes what we've found, and an Oregon Cancer Institute found that women who were getting BRCA tests and it came back negative were foregoing mammographies because they were inconvenient and they no longer considered themselves at risk. So this is actually a harm that could result from a false or a negative genetic test, not because it's an inaccurate result, but because the reassurance that's drawn from it is a false reassurance. Next slide, please. And finally, there's a type of neglected risk that I think is probably the most prevalent, that ethicists and LC researchers, that's ethical, legal, and social implications researchers in the genetics community, worry about the most. And these are the risks of overreaction. So there was an op-ed published in the Los Angeles Times back in 2015, which I think is very, very good at articulating some of these risks. They point to an example of a genetic test where the coming back positive would indicate that your chance of developing a particular disease was increased by 50%. And most people would think about that and say, 50% increase, oh my goodness, I have to do something about that. But when you understand that that actual increase in risk is from 4% to 6%, that's a very, what we might call inactionable increase in actual risk, right? You really aren't justified in doing anything differently based upon a 4% risk of manifesting a disease than you would at having a 6% risk of manifesting the disease, right? In both cases, you have at least a 94% chance of not manifesting the disease. So a radical intervention designed to mitigate risk would be uncalled for. And so overreaction to these results is a real problem. And it's a problem not just among patients, but is a problem among primary healthcare providers who are not trained in the interpretation and implications of genetic test results. Next slide. So that's it for my presentation. Is some of the risks that we've been focused on and challenges that have been have arisen in the use of genetic testing to fill gaps in family health history for adoptees. And I will now turn it over to Heewon to give you even more information in this regard.
Great. Thank you so much, Tom. I'm going to invite Heewon to join us.
Okay, I am ready here. I'm just turned everything on. Can you hear me, Holly?
Yep.
Okay, well, thank you so much for, Holly and the whole team, Red Adoption, also Greg, Rich, and Tom. It's been so great to hear everybody's story and research and perspective. One of the things that I can say is that, I'm Heewon Lee, I'm a genetic counselor, and I'm also a Korean adoptee. And so part of what kind of I was interested in before I even became a genetic counselor was just trying to understand my own biological, could I find biological family? What were my health risks? And so I've always been curious about that as well. I've done 23andMe. And I actually was, way before I went back to grad school and became a genetic counselor, I'm like, maybe I'll start a nonprofit and see if I can connect adoptees. So this was even before 23andMe was even started and became popular. But what the interesting thing is I think is, I went through school and I learned about genetics and I learned all about, the things that Tom and other people were talking about with the risks and the, over representation of things, also some of the neglected risks. Those are really important. And I really felt like the population of adoptees was a special population that we really do need to advocate for because we don't know what our family history is in general. And so one of the things I think about, coming to this both as an adoptee and as a genetic counselor is, what are the things that we really face as adoptees? And especially those of us who have very little family history would be, we don't know our personal risks. We don't know if we'll have a higher risk to develop cancer based on family history or something inherited. We don't know if our risk for heart disease or neurology concerns. So those are things that are pretty important to many of us, and especially as we age and have children, I certainly don't want to pass on things to my kids that I'm not aware of either, or maybe there's some screenings that they can start at a younger age to be proactive. I think many of us have been very frustrated with the medical community because there's a lot of closed doors. There are a lot of blank family health history forms. And for instance, I even went to see a provider recently and they said, oh, you're having some trouble with your joints. You should just look at your mom's hands. And they're probably, because you're young, it's probably something affected that she is affected too. And I'm like, well, actually I'm adopted and I don't have family health history and that should be in my chart. And so it's that constant sort of reminder and that you have to tell your health providers, I've seen you before, I'm adopted. Like it's that kind of thing where you want to make sure that people are really thoughtful when you see an adoptee or when you're heard as an adoptee. Next slide, please. So a couple of things that Tom and others were talking about, this direct-to-consumer testing versus clinical genetic testing. And so I kind of put up a little bit that you can compare a bit, like direct-to-consumer, a lot of us have done it. We know more about it. It's in the media, like 23andMe. It's self-directed. We can choose it ourselves. We can order it ourselves. We don't need a doctor's permission. We don't have to share it with insurance. The price has really come down. It used to be a lot higher. Now it's a little bit more affordable. But as Tom and others were saying too, it's very limited. So if you kind of look over on the other side, clinical genetic testing by a genetic counselor, genetic professional, medical geneticist, that is a provider ordered. The price can be higher. So I know sometimes people say, well, it's a lot cheaper to go to direct-to-consumer testing. But one of the issues and kind of the things to be aware of is that the genes that the test for DTC or direct to consumer are looking at versus like a clinical test, it's a lot different. So we would consider clinical genetic testing to be more comprehensive. So, if DTC looks at this much, clinical is going to look at this much. And when you want to look at your health more comprehensively, you really want that big picture. One of the other things to consider if someone's looking at a direct-to-consumer test is say, well, you don't really get a lot of support often. You don't have a medical geneticist or a genetic counselor. Like sometimes the companies will offer that support, and that's great that they're starting to do that. But not a lot of people think it's important, or maybe it doesn't come with it. But if you see a genetic professional, genetic counselor, you'll be there and supported throughout that journey to understand, like, what test are you getting? What is this really looking for? And what do I do next after results are back? And so that's the real benefit of having a genetic counselor or a professional there to kind of help walk through that whole process and journey with genetic testing. And then the last bullet I have here is just that there are a lot of privacy concerns and security issues when you do a direct-to-consumer test. So it's kind of every company has very fine print about can they sell it? Can they use it for third parties? Can they use it for research? Can they market it? Can they sell your data? Can it be in a crime database? Like all of those things are much more loosey-goosey, or just it's not regulated. You don't have as many protections in that direct-to-consumer realm as you would with clinical genetic testing, which is protected by HIPAA, which is a privacy law that protects your health information. And there's a couple other laws that protect you against discrimination for, health insurance and employer. So those are kind of the main comparisons. There's a lot more, but those are the kind of the first ones that I wanted to bring up. Next slide, please. And so I've been kind of talking about genetic counseling and being a genetic counselor, and not a lot of people, even when I meet with them, they're like, well, who are you? Why am I even seeing you? And so I talk with people and say, look, I'm just here to have a conversation, just to talk about, your personal history, your family history, how can we help you with genetic testing? What are the benefits? What are the limitations? Tom is absolutely right that, only 5 to 10% of cancer, for instance, because I'm a cancer genetic counselor, is associated with, having an inherited factor or a non-working gene that was inherited from a biological parent. And so, the vast majority of cancer is really random and sporadic, for instance. So there's a lot we don't know about cancer in particular. And what I think is hard for, being adopted is that we don't have that family history to sort of contextualize or situate our own personal journey, whether we have a condition or we're concerned about the risk for it. So absolutely, I agree that there needs to be a kind of a different kind of a treatment toward people without family history, whether it's adoptees, people who are estranged, refugees, donor children. There's so many different categories now that can kind of fit into that no family history thing. And I do think that, that dichotomy that Tom was talking about is very appropriate. Like, do you keep all of us adoptees at a population risk? That doesn't seem quite right. And yet, to go to the extreme and then overtreat us with mammograms and colonoscopies and other kinds of things, could be way too far. So I do think there has to be kind of a middle ground for adoptees. Next slide, please. So kind of what Tom was going over, as well as what I had a little bit of overlap here, is that, if you have family history on the left side, let's say your biological mother had breast cancer at 45, your screening would start 10 years prior. Same with colon cancer. Family history of a very close relative with colon cancer, your colonoscopy instead of 50 would start at 30. So these are pretty big jumps in some of this cancer screening. And I'm using cancer because that's, where I'm in right now in oncology. But definitely, even with a biological family member having like a recessive condition like cystic fibrosis or another kind of thing where you need two non-working genes that you would inherit from, both a biological mom and a father, they might, if you knew about it, maybe get some preconception genetic counseling and prenatal to say, well, maybe do I carry it? Does my partner, my spouse, the donor I'm working with carry this? And what should we know? Versus the other side where we're not getting mammograms until, 40 to 45, or we're not getting a colonoscopy until 50, or we're not even thinking about preconception genetic counseling because we don't know anything. And so again, that's a very big disadvantage not to have that biological family history, that genetic family history to sort of help us figure out what to do next. Next slide, please. And the last thing is kind of what I was starting to think about, like how can we open these doors to kind of advocate for our own healthcare, for our biological family, if we have children, or if we have any limited contact, is, be first very proactive about your own screening, like get your mammogram, get your cholesterol checked, go to see your primary care doctor every year so you can start building your own personal record. And then there are some risk calculators that are online called like the American Heart Society Association, and there's some cancer ones as well to say, well, based on this, my height, my weight, my exercise, what I do, there can be some very general risk calculators that can at least help you figure out, am I at a little bit higher risk or not? Should I talk about this with my doctor? My bullet there, advocate for yourself. Sometimes I'll go in and just be like, oh, I'm adopted, totally blank family history form. And then there's just silence. Well, what can I ask for myself? Let me get that screening. I'm going to, instead of a pap smear every 3 years, get one every year. Now, again, I'm not giving medical advice, but just things to think about. Like, I often will tell my own doctor, well, I don't know my medical history, so I'm going to be a little bit more proactive, a little bit more assertive about what I want to do. And then seek a genetic counselor. So, there are many genetic counselors over the country, wherever you are. I would recommend going to the National Society of Genetic Counselors. It's called findageneticcounselor.com, and look for a certified genetic counselor that has that training to interpret, talk about those tests. And even if you have a direct-to-consumer test, I have a lot of patients bring that to me and say, is this real? Should I get this confirmed? Absolutely. We talk through all of that. One of the things I'll say too is that in the past, clinical genetic testing with a genetic counselor or with a medical geneticist has been very high priced. Now, depending on what area you're looking at, cardiology, neurology, pediatrics, I can say for cancer, you can pay a cash price and it can be a lot lower than, thousands of dollars. It can be in the $200 to $300 range, which is still a chunk of change, but it is a lot better than it used to be when it used to be like $2,000 to do 1 or 2 genes. And lastly, just to consider the benefits and limitations of genetic testing is that, again, do you want to open that door? Are you ready to kind of confront those screenings or talk about it with your biological children? How do you work with your genetic professional to sort of, what is my risk? And because I don't have all those generations of family, how seriously should I treat this, or how aggressive should I do in my screening? So I always say, let's, put it back onto your team, your primary care, your genetic counselor to kind of help you through some of those testing and choices. And so that's kind of the end of mine. And then I just want to say thank you very much, and we'll open for questions, I think, when Holly's ready.
Great. Thank you so much to all of our presenters. So much information to process. So at this point, I want to open up the Q&A to those who are in our audience. And of course, I have some questions to our presenters as well. Oh, Greg, could you turn on your video again? If you can. Okay, great. So I have, okay, one question is just a more technical practice one. This is recorded, so I don't think we're going to be making the presentations available for download, but this is recorded and it will be available on our website in a couple of weeks when Amanda does her magic.
Holly, I can answer the first Q&A from Emma.
Yeah.
And what I can say is that actually, Emma, first of all, go Eagles. I'm a Boston College alumni. And also one of my former graduate students who's a Korean adoptee is a professor at Boston College, Omyo Kim, and she and I have done some research together on adoption. So I would encourage you to look up her in the College of Education, the Lynch College of Education in Counseling and Development.
So one of our questions we have is, I've heard direct-to-consumer testing for Asian populations is not very good. Like they'll just give you an East Asian, and do you have any other information about that? I don't know. Greg, do you want to?
Sure, I can comment a little bit. I don't have detailed information, but in general, the ability to infer the ancestry to a particular population or between two populations depends on the number of SNVs that are different between those two populations. And the more SNVs that there are different, the easier it is to say, oh yes, well, this person is of this ancestry or that ancestry. And it just turns out that for many East Asian populations, the amount of SNV differences is less than, say, SNV differences among Western European populations or certainly African populations. So, you know, if you're fortunate enough to be of African ancestry, there's a ton of information, you know, about, you know, which subset of African ancestry, you know, Yoruba versus San versus some other group. But it's harder, I think, for most East Asian populations. Southeast Asian is different, you know, because there is a lot of diversity among Southeast Asian populations. Now, of course, you know, well, I'll stop there.
Greg, also, isn't it the case that it's also based on sample size? So if there's not a lot of Koreans or Chinese taking these direct consumer tests, you're not going to have much of a sample to be able to draw from, correct? I mean, just as you were sort of showing how the ancestry numbers were changing. And
yes and no. So most of the ancestry inferences are based not on the customer base that the company has, but on reference panels that have been developed by scientists. And the companies are all using the exact same reference panels. Now, if a customer base becomes large enough, then the company will say, oh, we're going to use our own customer base to further refine our ability to infer ancestry. But there's a bit of a problem in doing that because, you know, then you're depending upon self-identified ancestry, which is in general not as accurate as, say, the reference panels that exist. Now, relatives, of course, is completely different, right? But
I have a question for, I think for Greg, and then it also relates to Rich's research, which is, did you know your ancestry, Greg, before you got your that part back? And did that change the way you thought, obviously? And then for Rich, you know, a person had commented on, and I've heard this among my adoptee friends as well, like I was, you know, adopted from Korea, but I am 50% Japanese. And what does that do in terms of one's sense of ethnic identity? So first, I'd love just, Greg, your experience finding out your genetic ancestry.
yeah, I mean, these are sort of very personal stories. And, you know, when you know, my parents, my adoptive parents, you know, told me, well, some babies come from their mommy's tummy and some babies come from the Jewish Adoption Agency. So, and at the time, I mean, now, I mean, this adoption agency still exists today, and now, they will take anybody. But 65 years ago, most of their, both adoptees and adoptive families were Jewish, but that was, of course, self-identified.
Yeah.
So, to the extent that, so the answer to your question is yes, it confirmed what I had always thought, but I was, of course, prepared for a slightly different result.
Mm. And Rich, do you have anything to add?
Yeah, I think, so one of the things I forgot to mention when I was giving my talk at the very beginning is the fact that, as Greg mentioned in his situation, and in the case of almost all international adoptions, these are closed adoptions, meaning that there is no contact with biological birth families. And one of the things that genetic testing provides is that it disrupts that closed adoption process. And it gives adoptees, as Heewon brought up, agency to make their own choices. And one of the ethical issues here is whose right takes precedence. Birth family, adoptee.
Mm-hmm.
And if we're thinking of ancestry, maybe the birth families take precedence. But if we're talking about one's health and one's future health, the debate can be then, isn't it the priority of the adoptee to have access and right? And so I do think genetic testing as a tool really sort of disrupts what historically, right, has been supported as a closed adoption process. Now, to the question around identity, we often do hear about people wondering, particularly if they don't fit the phenotype, right? And sometimes you will hear people in the Korean community say to a Korean adoptee, "Oh, you look half." Now think of what that can do to a person, right, who already may feel ambivalent or unclear about, how they belong to that community, and then to have that sort of statement made. And so, then people turn to genetic testing, but of course, even as we saw with Greg's personal example, like the percentages change, right? And so it's hard to give solid weight, I think, to ethnicity versus geographic sort of regions, right? And as we mentioned earlier, what was Korea was much larger than what is Korea today, right? What was China and what is China today is not necessarily the same. So I think it's a tricky thing. I mean, even I've done 23andMe, all sorts of things come up, and I know my family lineage. So I think it's a hard thing I think it gets at the fact that adoption as a closed process denies individuals information about their history. And that leads to ambiguity and uncertainty that can affect one's identity. And that's where the role of a parents and family and friends really play an important role in helping one shape an identity that is coherent and meaningful and enduring.
Sure. I have a question for Heewon and Tom, kind of going through my own health crisis, and you are just emotionally wrought and raw. And then you're given these risk percentages and you're like, well, what does that mean? And then understanding your own tolerance for risk. And I even struggled, and I understand statistics. So I understood that sometimes, I could have also opted for a mastectomy, but it wouldn't have given me any more protection than what I was already doing. And it was much more conservative to do just the radiation treatment that I ended up opting for. So if you could just talk a little bit, I mean, because you both talked about risks of both the tests and not the tests. And I love what you said, because you really reinforce that the tests can't replace family histories. But if you could just speak a little bit about how do people make sense of risk? And should the professionals be the one helping? Because often the person thinking about the risk might be in crisis.
Yeah, I think this is a set of issues that goes well beyond adoption issues as well beyond genetic testing issues. I think we're seeing similar issues of risk arise right now with the pausing of the Johnson & Johnson vaccine, right? So you're looking at a risk that at worst is something like 1 in a million versus what is the risk of COVID, so how people process risk, how they process iatrogenic risk versus natural risk, somehow people think, a harm that's inflicted through medical intervention, even if it's less severe, it's worse than if it just naturally occurred, seems to be how people treat those risks, right? So how people treat risks and how they respond to risk is individual in nature, is very varied, and I think is hard to quantify. But it's something I think is exactly the reason that we have genetic counseling recommended so highly in most clinical genetic testing, because making sure that people don't overreact or underreact to their genetic test results, or at least try to mitigate that risk, is, I think, very important.
Yeah, what a good question. And I think, sometimes I'll see people at different stages, like getting ready for surgery, or maybe someone has a family history, or maybe, someone found out that another person in the family has a genetic change in like a BRCA or a higher risk gene. So, you kind of have to figure out where that person is, why they're seeing you, and kind of like what do they have the capacity to intake, because it's a lot of information, right, that you get for surgery and radiation. And even if you have just a family history, you're like, gosh, this really brings up stuff from my mom or my aunt or my son. And so we kind of, genetic counselors really try to be patient directed, like where are you coming in, how are you interpreting your own risk, what's your knowledge of numeracy and numbers and statistics themselves, because I often I'll use a cup analogy, or I'll use different things to make sure that the idea of risk, or the quantification of risk, can be kind of handled in multiple ways. But definitely, what Tom said is right. It's really, everybody's really different. It's really hard to quantify. We'll try to use, in a person's lifetime. So I'll say, if this comes back, you might be at a higher risk for breast cancer, but it doesn't mean at 45, you're going to have an 80% risk at 46. It's more of, what is it across the lifetime, the lifespan? What can we do next? And how comfortable are you with, lumpectomy, mastectomy, colonoscopy, et cetera. And so we do talk quite a bit about, some people are like, that's fine. That's fine with me. I'll just, do whatever. I'm okay with that risk. And other people say, well, gosh, being a carrier really bothers me for something, even though they have a pretty low risk in some conditions if they're just a carrier versus if they have something that's a little bit more penetrant or disease causing. One of the things that really strikes me is that when I think about adoptees, especially in people without family history, is like, let's say we do genetic testing, something does come back in a genetic test, or something doesn't. So let's say something doesn't come back. So let's say a person has a personal history of breast cancer, they have genetic testing, it's completely negative. Well, if I saw somebody with a family history and said, oh gosh, you still have all these aunts and sisters with breast cancer, we're still going to screen you a little bit more aggressively. But let's say it's an adoptee and we don't know our family history, then we'll be like, well, we're not really sure what we should do next. Like, I guess it's just based on personal history. So it's such a bummer that we don't have some of those external extra sort of tools to figure out some familial risk or genetics.
Yeah. And I think, again, one of the themes of this conference has been connections over generations. And so what we don't know about our family history, our children won't know. And so that leads to another question around genetic testing and what can you ask for that will not only help you, but maybe help you understand your children. And then my other question is around that population, right? Because what we know in a lot of the disparities research is that the research is done not on Asian women, the recommendations for health screenings are often based on like white women. And so even that then can cause kind of a shift, right? If what we're basing health recommendations are actually not the population of which we are, we are. So I don't know if anyone wants to comment on that.
I think the first question you asked, maybe Heewon can answer around when parents are wanting their children to receive genetic testing or clinical genetic testing, because there are guidelines around that issue.
Right. I mean, I think one is preconception. So it's like if you want to know you're a carrier and if the person you're having children with is a carrier, that's really important even before pregnancy to figure out, could there be a risk of passing something down, recessively. And then the second is that, yeah, there are a lot of guidelines that really don't encourage, testing for children just because of the, there isn't autonomy, and the kids don't get to, really assent or give permission until they're 18. Now, there are some conditions that definitely kids need to be tested for at a younger age. And so that's something I would highly recommend, go to a genetic professional, medical geneticist to be evaluated. There's a lot of things that, they can kind of do step by step that may not even be testing, but could be different kinds of screening or work. But I do think that, in the cancer world, there's a few things that we see in childhood. So if we see a parent having a certain genetic change, we'll say, well, in general, it's, when they're 18 or older, you can see if they've inherited it. But there are a few things we'll say, well, the data and the guidelines really say not to get testing, but we can do screening. So because sometimes the testing for a young person is really traumatic and it can kind of shape how they make life decisions. But maybe they can have a screening for like their, thyroid or other area that might be appropriate if they know that they've got some parents or a parent with a condition. But it's very tricky, very tricky.
If I can add to what Heewon's saying as well, I think there's a lot of concern about stigmatization, and Rich might even be able to speak to this better than I, and that is the effect of knowing certain genetic test results on how parents might treat their children, and having a sort of certain self-fulfilling prophecies occur on the basis of that. So geneticists or the LC community often describes this as a right to an open future. And it's not being sort of boxed in by believing that your genetic test results are determinative of you going to be a certain way. And I think for adoptive parents anyway, one of the concerns I always have anyway is to realize that there are certain insecurities that adoptive parents can have about not being able to provide certain information. You have a child, you want to provide that child everything. And there's an insecurity that comes along with not being able to provide that information. And so the desire for genetic testing is there, and I think motivated to some extent by your needs rather than the child's needs. There are some things that can occur, childhood onset conditions that we can test for. Most of those are covered under genetic testing that occurs universally, at least in this country, newborn screening, right? And so I think that's why you see the American Academy of Pediatrics and the American College of Medical Genetics and Genomics recommending against predispositional testing of children genetically and limiting genetic testing to therapeutic or diagnostic testing where there is a manifest condition that you need this information to plan proper treatment or more optimal treatment, right? So those are considerations I think that have to be taken into consideration.
Yeah. I'm going to end just with one more question here because we are over time. It's 8:10. So I want to honor our participants. The question is kind of twofold, but essentially one is, if you do have access to biological family and that biological family is from another culture in which attitudes about health and medical information might be very different. And I know this in the context of South Korea. Koreans don't talk about their medical history. If someone has cancer, nobody tells that person, or it's not disclosed in the family. And it's very tied up into being marriageable and all these things. So health information is quite closed. And family members might not know. And so the Miju Kim is asking, what is it then should we be asking for if you do have access to biological family, if they don't have the same kind of thoughts around health history? And I think that's really important.
I'll just chime in this 2 cents. I think that might be true of everyone. I think that the amount of inaccurate family health history that we have is far greater than what we suspect, and I think family health history is a guide, but it's not infallible.
Right. I mean, I think from the perspective of, I'm not a prenatal genetic counselor, but something I would say that, I've worked with people from different cultures and they'll say, well, did somebody die very young? Which could be heart attack, it could be cancer. Was there a part of the body that was affected? Were there a lot of children that passed away as infants? Like things like trying to understand maybe some of the stories. If somebody's maybe not willing to say, oh, they had cancer, it was stage 4, it was this, and being able to kind of piece together, this grandmother, this grandmother was really sick, and then this daughter also had a female problem, and so then we can try to infer, or they had there's a lot of different ways to try to infer and try to figure it out, but it is hard because, I'll talk to families and they'll say, oh, everyone's healthy. I'm like, oh, okay. And so then it's hard to get that information for sure, depending on, what that relationship is and also what the culture is. So I feel for that.
Yeah. Rich, do you have a final comment?
Yeah, I just wanted to add that less on the health history side, but on the side of wanting to do genetic testing to find more information about one's birth family or one's ancestry. One of the things that we often will hear is that there's a narrative that adoptees who are interested in doing a birth search must be angry, unhappy, or ungrateful for their adoption. And what we know from our research is that that is absolutely not true at all, that there is no correlation between birth family curiosity and adoptive family quality relationship. And in fact, what we find is that birth family curiosity correlates more with healthy identity development and wellness, and that it is a natural part of one's life to have these questions. And that also then I could say probably extends to one's health history. It's not that one is uncertain or unhappy or overly anxious and nervous. It's a natural curiosity we all have to want to know something more about who we are and where we came from and where we're going in our lives. That is a normative process that's really important for people to understand, because there are problematic narratives out there about adopted individuals when they do something outside the norm. But the question is, outside of whose norm?
Great way to end this session. Thank you, Tom, Heewon, Rich, Greg, for your time, wisdom. And thank you all to our participants who joined us live. And we look forward to seeing you for the final session, which will be in May. Look out on your emails for information on that, and have a great night.